Today's lesson is fairly straightforward because it's just about finding area of certain shapes. And I'm not going to make you memorize these formulas. You may have to remember which one goes with which, but I'll give you a list of the formulas so you have them for quizzes and tests. So we're going to do three shapes. The first is a parallelogram. So a parallelogram, which we've talked about when we did the quadrilateral lesson, but it's a four-sided figure whose opposite sides are parallel. And just in case you don't remember what they look like, there's examples right here. So rectangles and squares are parallelograms. There's special kinds of parallelograms, but they still fall in that category because their opposite sides are parallel. So the formula for the area of a parallelogram is just base times height. A represents the area, of course. B represents the base. And H represents the height. And the base and the height for parallelograms are always perpendicular. If you notice, all four of these have a right angle labeled. That's showing you that the lines that are connecting them are perpendicular. So for example, this is the height and this is the base. Well, actually, let's just do this. We'll label it. So the base is typically labels the bottom, though truthfully you could use the top as well because they're both the same length. So that's the base, and then this line is the height. So that's one important thing to remember is the height is not always a side of the parallelogram. It's often this dotted line. It just depends on the shape. Because here, this is the base, and you could call either one of these the height. It doesn't matter. On the square here, this is the base. This is the height. Here is the base, and here is the height. So when they're slanted like these two, it's important to remember the height is not going to be the length of one of the sides. It's going to be the line that's perpendicular to the base. Perpendicular means it'll form a right angle. So let's try to use the formula here on this one. The formula is A equals B times H. Now as we look at this, 6 is the base. So we plug in 6 for B. And the height is this dotted line right here, because it's the line that's perpendicular to the base. So it's tempting sometimes to use this as the height, because it's like, okay, I use this side and this side, but it's not true. We use the base and the height. So we put in 5 for the height. So the area is 30 centimeters squared. You always square the units when you do an area. Okay, find the area of the rectangle. A rectangle is a parallelogram. So you can use length times width. It's really the same thing, but we'll just use base times height since we're calling it a parallelogram. The base for this one is 4 because it's right there, the base. And the height is 5.5. So when it's a rectangle or a square, the height is a side. But when it's slanted like these, the height is not a side. So 4 times 5.5 is 22. And we write centimeters squared, or square centimeters, for the unit. Okay, number 2, find the area of the parallelogram. Now this may seem weird, but essentially they've turned the parallelogram that's more like this shape, and they've turned it on its side. So if it's easier, just look at it this way. Then it might be easier to see that this is the base and this is the height. So they can turn it on its side like this, and it may feel like, well, wait a minute, how can I call this the base? Sorry, let me make that visible. You're like, how can we call this the base? Because that's on the side. Well, it's just because they've tipped it to its side. So if you look at it this way, you can tell 7 is the base and 2 is the height. Because when you turn it this way, that's the bottom and that's the height. So we'll write area equals the base 7 times the height 2 and get 14 square centimeters. Okay, I think that's enough parallelograms. I think you get the picture now. So next up, we'll do triangles. And I'm not sure this is exactly the order you have them stapled together. Sorry if I'm in a different order than you, but turn to the page that says triangles. So I think you've known what a triangle is for a long time in your life. But a triangle is a figure with a figure with 3 straight sides and 3 angles. And the area of a triangle is half times the base times the height. So it's very similar to the area formula for a parallelogram, except that it's half times the base times the height. And as you can guess, A represents the area, B represents the base, H represents the height, and just like it was with the parallelogram, the base and the height are always perpendicular. So let's practice labeling these. This would be the base. This dotted line would be the height. So similar to the parallelograms, the height isn't always a side. It can be, but it isn't necessarily that. This is the base. And on this one, with an obtuse triangle like this, the height is actually found outside the triangle. It's this dotted line over here. And here's an example where the height actually is a side of the triangle. Because remember, they have to be perpendicular. Since this is a right triangle, they're already perpendicular to each other. They form a right angle. So the base and the height are both one of the sides of the triangles here. Then those wicked math geniuses here, they are tipping sides over again. So you can think about this shape more like this. That's the base. That's the height. You can pretty much guarantee if there's a dotted line, that's the height for both parallelograms and triangles. Okay, so the formula for a triangle is half times base times height. So in this one, our base is 5. Our height is 4. So we'll do half times 5 times 4. That gives us 10 centimeters squared. Formula is half times base times height. You're not required on homework or quizzes to write the formula first. You can if it's helpful, but you don't have to. You can certainly just start by writing 1/2 times the base, which is 6, times the height, which is 4. So half times 6 is 3. 3 times 4 is 12. So we have 12 square centimeters. Now I have one of those weird ones that's an obtuse triangle, where the height's actually over here outside the triangle, because the triangle itself is this part right here. But to figure out the height, they had to go outside the triangle to the left of it. So we'll do half times the base, which is 7, times the height, which is 5. And you are allowed to use your calculator for these. This one will be 17.5 square meters. The last one, last one we'll do on the triangles. They've tipped it on its side again, so if it's easier, you can look at it this way. This is the base, and this is the height. So the 9 meters is the base. The 2 meters is the height. Because those are the only two lines they give us that are perpendicular to each other. So that's why we have to think about it from this direction. So we'll do half times 9, because that's the base, times 2, because that's the height. So we end up with 9 meters squared. Okay, let's save the best for last. Talk about trapezoids. So trapezoids, you can see some examples of some pictures down here. There's some below that too. But trapezoids are a figure with exactly one pair of parallel sides. So while parallelograms have 2 pairs of parallel sides, trapezoids have just 1 pair of parallel sides, and only one. And the 2 sides that are parallel are called bases. The formula for this is 1/2 times the height. Then you have to put parentheses and write base 1 plus base 2. And these are just a little 1 and a 2 just to identify it's 2 different bases. So there's nothing calculating wise you need to do the 1 and the 2. It's just saying we have 2 different bases. So this is base 1 and base 2. And it doesn't matter which one you call base 1 or base 2. Because they do always write the formula this way. Honestly, I wish they'd put the h at the back. And the reason is, the reason we have a 1/2, the reason I wish they put the h at the back, I think it's easier to understand why we have a 1/2 if they do that. Because what they're actually doing with the bases, is we're finding the average of the 2 bases. So like here's a base. I'll go ahead and label this one base 1 and base 2. They're finding the average of those 2 bases and then multiplying by the height. So that's the reasoning behind this. We're finding the average of the 2 bases. We add them together, divided by 2, and multiply by the height. So A represents area. H represents height. And B1 and B2 represent the bases. And yet again, the bases and the height are always perpendicular. Okay, so I already labeled this one. You can fill that in if you need to. I'm going to do the bottom one next. Again, it does not matter which one you call base 1 or base 2, so I could say this is base 2 and this is base 1. It's not at all an issue of whether one's on the bottom or top, just these are the 2 bases, period. Then this dotted line is the height. Now if you go back to the definition, as we just look at this one right here, the two parallel sides are the bases. So understandably, you'd be tempting to say that's the base 1 and base 2, but they're not. We have to look at it this way because these are the two parallel sides. So that's base 1 and base 2. And then the height is perpendicular to that. So that's the height right here. So base 1 and base 2, and if you're looking at it this way, it makes sense that's the height of the shape. So let's just practice a few down here, then we'll be done. So the formula is half times the height times base 1 plus base 2. That's probably the last I'm going to write it on that line because that line's too small for that. Why do they do that? So we have 1/2 times the height, which is 4, times base 1, which is 3, base 2, which is 5. And again, if you said 5 plus 3, that won't make any difference. You can call either one base 1 or base 2. And I know some of you have asked me before, like, can we just do this part first? Like, ignore the 1/2, do this part first, then divide by 2. You certainly can. Multiplying by 1/2 and dividing by 2 are the same thing. So it's fine if you want to just do this piece, then divide by 2. 3 plus 5 is 8. 8 times 4 is 32. And half of 32 is 16. So we're still doing area, so we still have to square those units. Okay, on number 2, we have half times the height, which is 5, times base 1 plus base 2. So we get half times 5. 7 plus 4 is 11. So 5 times 11 is 55. And half of 55 is 27.5 square feet. Okay, on this one, number 3, we got 1/2 times the height, which this time the height is 6, because that's the side that's perpendicular to the bases. So the height is 6. Then we do base 1 plus base 2. 8 plus 6 is 14. 14 times 6 is, I think, 84. And then half of that is 42 square centimeters. One recommendation I would have in your calculator when you're plugging this in. Now, if you are good with parentheses, it's fine to just type this just as it is. You could type 1 divided by 2, or if you want to, you could type in 0.5 times 6 times parentheses 8 plus 6. That will work. Or you could also just type 8 plus 6, hit enter, then do times 6 times 1/2, or times 6 times 0.5. That'll get you the answer. But you want to make sure that 8 plus 6 happens together, or else you'll get the wrong answer in your calculator. Last one, 1/2 times the height, which is 4 inches. Base 1 plus base 2, that's the 10 and the 7, because those are the two parallel sides. So again, in your calculator, either do 1/2 or 0.5 times 4 times parentheses 10 plus 7. Or if you can do that in your head, you know it's 17. You could just say 1/2 times 4 times 17. Or if you want it in your calculator, just type 10 plus 7, hit enter, then multiply by 4, then multiply by 1/2. But you get 34 square inches on this one. Okay, just make sure you have the formulas nearby you as you're going through the work for this, and good luck.